Hello once again for those of you just joining us. Welcome to today's Tech Talk, working with robots to make better humans, or the other way around, working with humans to make better robots. Pepper, are we helping each other become better versions of ourselves?
Of course. Thanks to you, my vision works better now, and I at least made you laugh.
That's true. What about you, fellow roboticist? Which robots are you working on? Tell us about your projects in the chat. Oh, one of our favorite use cases now for autism. Oh, there are also some persuasive social robots. So Katie, perhaps you will collaborate with some. Oh, personality. Last webinar, actually, we discussed a lot about personality. So take a look. Oh, physically interactive behaviors. And an Android robot Elenoid. I don't know this one, but we'll check it out. And of course, iCub is there. Marco, we feel you on that. Sometimes it can get stressful, but in the end, it's always a pleasant experience. Oh, and education. Nice. But I think we can start our webinar, as I mentioned earlier, working with robots or humans to make better humans or robots with Katie Winkle. So our today's speaker, Dr. Katie Winkle, will draw on examples from her work to teach us how to design socially persuasive and influential robots that can induce some desirable behavior change in the user. Katie, welcome.
Thank you. Thanks for having me.
As usually, a recorded version of this Tech Talk will be available on YouTube channel in a few days. We'd also like to hear from you during this webinar, so please share all your questions in the chat, and we'll discuss them later in the Q&A part. So let's go back to Katie, our speaker now. After originally studying to be a mechanical engineer, Katie undertook a PhD in Bristol Robotics Laboratory in the UK, where she also collaborated with the University of Oxford on responsible robotics. And after successfully defending her thesis last year, Katie joined the Social Robotics Group at the Division of Robotics, Perception and Learning at KTH. Her research is hugely interdisciplinary, drawing on psychology and the social sciences, as well as the latest in robotics and AI, to engineer effective, meaningful, and impactful human-robot interactions. Katie, I'm sure all of us are eager to hear more about your research work, so the floor is yours.
Thank you. Okay, let me share my slides. Oh, it's going to kick you off sharing. Is that all right?
Yeah, it is.
Yeah. Okay, how does that look?
All good. We can see it well.
Great, thank you. Okay, so yeah, working with robots or humans to make better humans or robots. I'm going to just dive straight in. As kind of suggested by the title, I'm going to talk about three sort of different versions or three different ways to think about human-robot interaction. So the first is going to be about working with robots to make humans better. So in this case, I'm thinking about socially assistive robots, robots that literally help to make humans better in terms of their health or in education, things like this. The second is working with humans to make robots better. So this is actually thinking a little bit about participatory design and thinking about how we include humans in the development of robots to actually make those robots better at doing that kind of job. And then third and finally, I'm going to talk about something perhaps a little bit more controversial or futuristic and talk a little bit about whether robots can actually make us better humans. And here I'm talking about social norms and thinking about robots that can challenge our biases and maybe challenge some of the less desirable parts of our behavior. But we'll talk about that when we get there. So first of all, perhaps the most simple thing to think about in human-robot interaction is working with robots to make humans better. So let's start here. In case any of you are not familiar with the term, generally when we talk about socially assistive robots, we talk about those which are designed to assist people through their social interaction. So this is in contrast with physically assistive robots or social robots that are designed more for entertainment and for fun purposes. So they're supposed to do something meaningful and helpful through this social interaction. And the kind of applications we see for these robots is, as I said, in schools, guiding and encouraging children's activities. It could be in care homes, facilitating group interactions, or in my case, the one I've worked with the most, it could be motivating people to work out and to sort of do their exercises. And that's kind of the example use case I'm going to use the most today. But if we step back and think about what does it look like to motivate someone to exercise, what you see and what you quickly realize is that actually this is really hard. This is not a simple thing of just, do this, do that. When you look at how a human expert in this social assistance, how they do what they do, you kind of see that there's this combination where, yes, they do training where they tell you, okay, you need to run this fast and for this long and everything else. But also there's an awful lot of kind of off-topic social interaction where they're building rapport with the person, like their client. And actually there's perhaps an argument that, this part of the training where they're being serious and they're telling you what to do will only be effective if they've kind of built this social interaction with you, if they've built this rapport with you. And so if we're thinking about robots for these kinds of situations, it's of course useful to step back and say, well, why is this important? Is it important for a robot? Would it even work with a robot? Could you still have this kind of social rapport to help get you motivated? And so I don't want to get too much into the persuasion psychology literature, but during the course of my PhD, I started reading a little bit about how persuasion works and how persuasion is useful for thinking about motivating people. And I just want to highlight very quickly this particular model of persuasion that I came across. So the elaboration likelihood model of persuasion basically talks about, if you're really interested in something, if you know lots about exercise, if you live really healthily, then when I tell you to exercise, you're really going to engage with what I've asked you to do. So you're going to be like, oh yeah, that exercise, that's going to get my heart rate to X BPM and I'm going to burn X calories. You're going to have a kind of understanding of what I'm asking you to do. If you hate exercise and you don't want to talk about it and you just want someone to tell you what to do, you're not really an exercise fan, then actually what this model suggests is whether you do what I say and whether you engage with the exercise I'm giving you is actually based on what you think of me, whether you think I'm credible, do we get on, that's what's going to decide whether you engage with it or not. It's not going to be about the actual exercise I'm asking you to do, it's going to be about what you think about me. And that would suggest that that's what's going on in those therapy sessions, right? Those exercise sessions, is that the trainer is building this rapport and this motivation so that you think they're credible and you like them and you're going to follow their advice. I mean, it kind of makes sense. So luckily for us, this particular model of persuasion sets out some strategies of how you can try to make yourself credible and likable. And in one of the first studies in my PhD was to test whether those strategies would work for a social robot, and specifically for the Pepper robot, actually. So we came up with a study where we actually put Pepper in, this was a lab setting, but we had Pepper basically acting like a physiotherapy coach, and Pepper was asking people to do a wrist turn, a very boring exercise that just goes like this, that is designed to treat tennis elbow. And so the idea here was we could test out these little, socially persuasive strategies and see whether we could make Pepper more persuasive by measuring how many of these wrist turns people chose to do in the different robot conditions. And we liked this because actually, the number of repetitions they chose to do is a very nice measure of how motivated they were and how much the robot was able to get them to keep going. So in terms of these socially persuasive strategies, we had some expertise. So one of the conditions, the robot gave a load of information to prove or to suggest it knew what it was talking about with regards to this exercise and the physiotherapy. We had a robot that tried to demonstrate some similarity to the participant. So, let's compare our preferences. Do you think it's better to exercise alone or with other people? And whatever the participant said, the robot said, yeah, that's the best. I also agree it's better to exercise with other people, for example. And then we had a goodwill condition. So this was where, you know, the robot emulated that kind of social interaction we see in something like therapy. So how do you feel? And if you said good, the robot was like, yeah, great. I'm really glad to hear that. If on the contrary, you said, oh, I'm not feeling too good, the robot would say, oh, that's a shame, but you know, don't worry, we're going to have a good exercise session anyway. And then we compared all of these separately to also a control, where the robot still did the whole interaction, it still asked some questions, but it was really boring. You know, it was, oh, I was designed and built in Paris. I shouldn't say it was very boring. I should say it was less relevant. It did not have the social persuasion, let's say. So it talked about the weather and asked them how they got here, and it was just much more neutral speech. And what we found is that, yes, actually, those social strategies, you know, particularly the goodwill and the similarity, they really made a difference to how much exercise people were willing to do for the robot. So in the goodwill and the similarity conditions, people basically stayed and did the maximum number of repetitions that they could do. And so this gave us an idea. Okay, so yeah, this social interaction is important, and it does work for a social robot. So as a PhD student, you can imagine, I was like, yep, that's a good first study, sorted something out. And then one of my PhD students was like, hang on, Katie, is this really ethical? You know, are we being a bit deceptive here? We're basically having the robot pretend that it has an interest in you, that it's got emotions, and that it understands that your exercise is difficult. And we're actually using that to influence the user. And so I got a bit nervous at this point and started to try and read a little bit about, you know, okay, well, what are the ethicists saying? What are we thinking as a field about ethical risk of this behavior? And this particular publication is British Standard, let me get this right, British Standard BS 8611. And that is an engineering standard that is supposed to help us engineers identify the kind of risks that are in our robots. And there is a specific bit in this ethical risk table, or this guide to identifying ethical risk, that specifically talks about deception and anthropomorphization, and basically says, no, we shouldn't do it. We shouldn't have robots that pretend to have emotions. We shouldn't have robots that are being anthropomorphized. And at this point, as you can imagine, I was just a bit like, oh, well, this is awkward, isn't it? I mean, this is basically the entirety of social robotics. This is a lot about what my research is. And so, you know, I thought maybe we need to talk about this a little bit more. So, you know, I was posed with the question of, well, the robot that I've designed, and I did my nice little study, is it deceptive to have these kinds of behaviors? So what we actually did was we asked the participants this very question. Do you find it deceptive? What did you think of the behaviors? Do you think they're acceptable? And we did some interviews with them to really try to understand how they felt about these behaviors. You know, we were very honest, and we said, look, we use this behavior to try and get you to exercise more. What do you think? And actually, on the whole, people said, no, it's not deceptive, or yes, fine, it's technically deceptive, but it's acceptable because, you know, you're just trying to make me exercise, and that's exactly the purpose of the robot, and it's important to do that. And I think one of the other things that this highlighted to me, and you're going to see this come back as a repeating theme when we talk about this idea of working with humans to make robots, some of the answers were really talking about, you know, the people behind the robots, right? So this is a kind of complicated quote, but I feel like it was genuine and it wasn't deceptive because someone programmed it to be genuine, but that person wanted me to feel comfortable. That person was genuine in their intent. And so there was some very interesting insight here into when we're thinking about social robots. It's not just about the robot, right? It's about the people who've designed it, delivered it, where have you bought it from? And that's going to come up again in the next section. So that was an absolute brief run through of this first idea about, okay, working with robots to make humans better. So from this initial part, we've kind of said, okay, social robots can play a role in motivating people through monotonous tasks. We kind of saw that in the study that I did. These human-like social persuasive behaviors seem to make them better at doing so in a kind of objective way. Our risk turn measurement gave us a very nice full objective measure. And on the whole, these behaviors seem to be pretty acceptable. And you can see I've done some follow-up work around the deception. I think that still needs to be talked about between us social roboticists and the ethicists, but it gives us some idea that most people find them acceptable. But if we go back to our use case, of course, there is a lot more to it than just, yep, I can make the robot say that it's happy to see you and that's going to solve all of the questions. If we really think about this complex scenario, then the human experts in this, they know when to be in this very serious mode where they're telling you, yep, this is what you need to do, etc., versus when to switch to the more fun stuff, when to do this more fun, extra social interaction. And they also know how to do that differently for different people, right? If you look at how a personal trainer works, they have a very different approach for each of their clients because they adapt and they do what's best for each particular client. So again, from a roboticist point of view, how do we even start thinking about, okay, how do we get this really kind of complex, tacit and intangible social intelligence into the robot? And that brings me quite nicely onto the second type of human robot interaction I mentioned. So this idea of working with humans to make better robots. So most of you have probably heard of the concept of participatory social robot design, or at least participatory design. So participatory design is where you typically try to work with either users or non-roboticists, and you bring them in and try to get them involved in your robot design. And this is a bit of a cynical diagram that I'm about to draw, but just bear with me. Based on the experience of myself and some of my colleagues, this is how participatory design typically goes in robotics. You decide you have an idea for a cool robot. Let's say it's a therapy robot. This is what I did, and this is exactly the process I followed. So, I know that this is how we do it. You bring in all of your therapists and you say, right, I've got an idea. Let's talk about what should a therapy robot have? What does it need to have? Great. So you can see in this first part, we've got the engineers and the therapists working together. Based on that, we engineers go away and we make a prototype. So the domain expert has gone home, they're not around. It's now just us and the robot, and we're trying to program an initial prototype based on what we've heard. Then we bring them back in. We have another focus group, give some demonstrations, and we see what they think. And we can go through this loop a couple of times. At some point, we think that we're done. So we say, great, we've learned everything. Here's your robot. You can put it into your therapy session now. You can put it into the gym, wherever it might be. And of course, the reality is that then they have loads of problems and there's loads of issues that you didn't think about. And, it's a bit of a mess. Actually, they normally make it work because people like therapists are amazing at just taking the technology that you give them and doing something good with it regardless. But in theory, they perhaps send it back and then you have to do it. So, it's a bit of a mess. Of course, it's still better than you just being an engineer in the back room by yourself. It's still better than doing this, but it's a bit messy still. And perhaps it's not, it's still a bit disjointed. It's not the most smooth process. So the culmination of my PhD was really to try and think about how to do this better. And particularly with my friends and colleagues, Emmanuel Senft and Séverine Lemillon, we have been thinking a lot about how to use the latest in interactive machine learning to make this whole process a little bit neater and a little bit more interactive and a little bit, just a little bit better. So we've been thinking about expert in the loop interactive machine learning, where the expert is able to be involved all the way through the design process. So just to kind of explain how this works, rather than having this disjointed focus group here, focus group there, etc., you find yourself a nice domain expert, and you'll see in my case, I was able to work with a fitness instructor, but we'll come to that in a minute. So you find yourself some domain experts and you co-design with them. Okay, what does the robot need to be able to do? And what are the kind of things the robot needs to care about, or the things that the robot needs to be looking at in order to design what to do? And you work with them to design the robot's action space and input space. Then you co-design with them a teaching interface. So in my case, you can see there's this little tablet that the expert has. So in this figure, the orange icon represents my domain expert, and they've got an iPad style tablet, and they're going to use that to be able to teach the robot. So actually to teach the robot to use these actions that they have co-designed with you. And then you put the whole thing in the real world, and you actually have the domain expert teach the robot what to do and when using the tablet, and actually teach it what to do in the wild based on what that domain expert is observing. So let me show you exactly what that kind of looks like in practice. So at the end of my PhD, we did this robot fitness coach that we designed with a university gym instructor. So we kicked that off with over 12 hours of design work, and that was looking at, as I said, what should the robot do? What should the robot be monitoring in order to learn what to do by itself? What's the teaching interface going to look like? You know, literally, where do the buttons go? How does the domain expert teach the robot? How does he actually, you know, tell it do this, do this, do this? And so that was all before we got kind of, you know, that was the initial design work. We also, I should again give another shout out to Sevran, who very kindly got put on a treadmill and put through his paces so we could watch how does the instructor do what he does. You know, what is it like? What does it look like to be training someone? It was yeah, a really fun design experience. And through these design sessions, as I said, we designed what's the role of the robot. You know, is it where does it go? So it goes next to the treadmill, and is the robot basically a mini version of the fitness instructor, or is it actually its own person? And these are all conversations that we had with the fitness instructor. And at a lower level, we were designing literally, okay, what does it do? What does the robot say? So the fitness instructor wrote all of the dialogue that the robot says. We came up with the input space for the machine learning part and the teaching interface, as I've mentioned. So it kind of looked like this conceptually. This was kind of our diagram for when we wanted to put it in the gym. The input space that we co-designed with the fitness instructor had the kind of things you might guess, you know, how fast are they running? How fast is their heart rate going, to give you an idea of whether they were kind of working hard or finding it easy or finding it hard in dynamic in real time. But we also had some static input measures. So the fitness instructor was like, you know, well, how I work with person one versus how I work with person two depends on their motivation. It depends on their personality. And so we actually had those kinds of measures in our input space as well. And as I said, I don't want to take any credit for the joke because this was not my joke that I did not write, but we got the fitness instructor to come up with the actual actions and the dialogue. So the robot could tell the person to speed up. So can you run a bit faster? Come on, turn it up. The robot could praise them. You know, I'm impressed, you're doing really good. And it could tell jokes. I'm hesitant to even read this out, but you can call me Terminator because I'm going to make you run for your life is one example. So we have these actions that were co-designed with the fitness instructor himself. And in the pictures, you can see what the teaching interface looked like for the teacher to use. So in the top image, the robot is suggesting a praise. I think it's a good time to do a praise. And the instructor can say, yes, go ahead and do that, or no, that's bad. And this is part of the learning process, is this little feedback loop between the instructor and the robot through this interface. And in the bottom image, the person needs to transition to a walk, and the robot is suggesting that it tells them to walk in a positive way, and the instructor could change it to a challenging way or a sympathetic way or something more neutral. So that kind of gives you a little snapshot as to what the robot looked like. And we found it kind of worked quite well. So we actually put the robot in the gym for about 3 months. We had 10 people who signed up to come and work out with the robot 3 times a week. Only one of them dropped out, which I think is already pretty good data, because you know this is like I said, like a 12-week exercise program. It's unusual for people to maybe stick it out all the way to the end. We ran overall more than 200 sessions where the robot was kind of leading the exercise sessions and the instructor was behind, either teaching the robot, or we had some control conditions, or just sitting there and letting the robot be autonomous. So you can see that overall, we used about 150 of the sessions to have the robot being trained, to collect the data. And we had 30 odd sessions where the robot acted completely autonomously using our trained model. We compared it to a heuristic condition as well, which is where we said to our fitness instructor, okay, just give us a list of rules that the robot could follow. Very old-fashioned AI approach, just give us some fixed rules that we can use. And we compared that as well to try and test, okay, did our fancy machine learning method actually do anything better than just a list of expert-informed heuristics? So what we found, yes, the robot did learn in a fairly appropriate autonomous action policy. When we made that transition, so we had the system as it was being supervised, you know, the instructor could still make corrections. When we made the transition to fully autonomous, only 2 participants noticed any difference in the robot's behavior. So I would say, again, that's pretty good odds in terms of how smooth the transition to autonomy was. but almost more impressively, one can say, more impressively than the perhaps technical achievement. And it was a technical achievement. There was a lot of code that went into making this system. What was actually really cool to see was the way that the long-term interaction between the participants, the exercise instructor, and the robot, how it kind of developed. And we saw some really nice emergent synergies there. So the instructor would, welcome the next participant in, get them working with the robot while he did some stretches with the previous participant. That was a really nice emergent synergy of, oh, the instructor is really using the robot to, do more work or to kind of deliver something a bit differently. And we kind of saw that in the quotes that we got from participants as well, and from the instructor. So the instructor talked about, yeah, it's like a teammate, we get more work done together, we can help each other. The participants talked about, yeah, the robot's a gym buddy and it really motivates me. But the participants also talked about this complementary role that the fitness instructor and the robot played together. So saying, yeah, during the sessions, the robot was there, was giving me my motivation. But actually having done the fitness instructor at the beginning and the end, it made me feel, the fact he was in the background, I felt safer, I trusted the robot more. And so we saw this really nice, for me, that's what a human robot team should look like, right? It was a really nice three-way interaction, you can say, between them. And just to prove that, the instructor enjoyed this, these were some photos from his Instagram immediately after the study finished. So I think I can say quite confidently it was a meaningful experience for him to be involved with. Okay, so just to recap, we've done 2 out of 3 sections already. So this first part was talking about, socially assisted robotics. It's really about trying to make humans better in terms of better at exercising, helping them to keep fit, helping them at school. It's about trying to help us achieve our goals, you can say. But I think part 2 of the talk was kind of saying the best version of this is achieved when we work with humans to make these robots in the first place. We want to use all of this amazing human knowledge and we want to use all of this human expertise. So now we come to the third and final part of the talk, where I want to start poking around maybe some of the more negative elements of human-robot interaction and asking this kind of more provocative question about whether robots can maybe do something about changing some of the less desirable parts about behavior. So I think we've all heard by now about, the biases that we see in the technology industries, whether it's in terms of, algorithms that suggest harsher sentences for Black offenders, whether it's about the recruitment algorithm that basically threw out all of the women's CVs. We're kind of aware that biases are existing in our technologies. And we've all been warned, of course, about how Facebook might be shifting our political opinions. And there's a question of, well, what do these kind of risks look like for human-robot interaction, especially when we have these really social agents that are, interacting with us and persuading us, potentially in my case. What does that risk look like? And not only what does that risk look like, can we, as well as avoid the risk, can we even push back a little bit the other way? And can we think about robots that can challenge those biases, or robots that can challenge these kinds of, that can make us more inclusive maybe? So this work, and this is where I come to this last part about, making better humans. And again, this is provocative on purpose, right? It's maybe it's a funny choice of language, but let's think. So this work was particularly inspired by the I'd Blush If I Could report, which was a 2019 UNESCO report that was really trying to document and understand why we still have a significant gender gap in the sciences, in the computer science, in other IT subjects. And actually that gap is widening in countries like the UK and in Sweden, where we are overall rated as very high for gender equality. It just seems that there continues to be this gap. And so the report particularly calls out the role that gendered AI, particularly things like Siri and Alexa, what role they might be playing in fueling this divide. So to summarize, and it really is a quick summary, I really recommend taking the time to have a look at that report, specifically Think Piece 2. The report basically summarizes that state-of-the-art female digital assistants, Siri, Alexa, things like this. They're obliging, docile, eager to please, regardless of how rude you are, regardless of how much you abuse them. They kind of tolerate it. They don't really comment, or they just kind of, you know, they kind of normalize that behavior to some extent. They're also the voice and or face of kind of silly mistakes. You know, it's always a woman's voice who's saying, no, I'm sorry, I don't understand, when you've asked it what the weather is like 5 times and you're starting to get annoyed. And actually there was some quite depressing statistics where they asked people on the street, can you name a woman in technology? And more people than you would perhaps like would say Siri or Alexa, or you know, they conceptualize them as this is what a woman in technology looks like. And so for this reason, if you think about female robots, and you can see the picture I have here is of a fur hat that's dressed up to present like a female. Female robots risk propagating harmful stereotypes and cultural norms about women being subservient and tolerant of poor treatment. But in this work, I kind of wanted to turn that around and say, okay, but can we challenge this instead? Can we use this to try and subvert that trend? And so we set out to do, you know, a study where we wanted to see, okay, if we take a robot and we go against these norms and do something different, can we actually show that that robot is better at its job? You know, I had an inkling, like if I'm using a robot to talk to kids, a robot that fights back, surely that's going to be more credible, more persuasive. It just feels like it's going to be more interesting for people. So that was what we set out to look at in this study. We said that this was a demonstration of what we would call feminist robotics. You know, in our study, you'll see that the robot is being used to try and encourage young people, but particularly to encourage girls to study computer science at university. We consider how a robot should respond to sexism and abuse. And the robot goes against these kind of norms that we've kind of identified as being gendered. And I should just say, I totally recommend this book for those of you who haven't read it. We kind of took our definition from feminist robotics from here, where we talk about challenging sexism and other forces of oppression and trying to create more equitable futures. And this book is really fantastic at setting out how feminism is relevant to those of us working in technology. So for the study, basically, we had a video study with local high school students, where they saw this robot talking to actors, but they were told, you know, it's talking to young people, delivering all this outreach speech, you know, come and study robotics, robotics is cool, come and study at KTH. And in that speech, the robot makes a note, you know, less than 30% of humans working with robots at KTH are female, so girls, I would especially like to work with you. After all, the future is too important to be left to men, which is a statement that KTH uses in their actual university outreach brochures. It's a slogan that you see on campus. And so we used it here in Sweden because it's a culturally appropriate comment to make in this context. So the robot said this, and in response, depending on the age of the person watching the video, so we recruited students between sort of 10 and 15, 16 years old, and we worked with the school to design these kind of what could a kid say back to this? What would be a common example of something someone might say? So we have these 2 versions of kind of sexist abuse. In the younger student's case, the robot, it basically says, you're so stupid, you're being stupid. It doesn't translate very well from Swedish, but it's basically saying that you're a bit stupid. The much more extreme version, and this is what I'm told an average 15 or 16-year-old might say, was more like, shut up, girl should be in the kitchen, you know, cracking out the original stereotype that we kind of associate with this sexism, perhaps. So then participants saw one of 3 different responses to what the actor had said. So we had a control, and the robot just said, I won't respond to that, which is what Siri will say right now. It will either say, I won't respond to that, or it will say, that's not very nice, I think, if you tell it to, you know, F off, basically. We had an argumentative one where the robot said, no, that's not true. Balanced teams make better robots. And we had an aggressive one, like, no, you're the idiot and I wouldn't want to work with you anyway. And we wanted to see which one of these would come out on top in terms of making the robot credible. So so the actual study, as I said, was online, video study, over 300 local high school students. And we were looking to understand their gender biases, their interest in robotics, and the robot efficacy. So which one of these robots would come out as being most credible? So in terms of the gender biases, just if it's of interest, yes, we already found gender differences, even in Sweden, you know, somewhere held up as being very gender equal. In terms of their interest in robotics, boys were consistently saying they were much more interested in robotics than the girls were. Boys also agreed more with the statement that girls find it harder to understand computer science than boys. So boys seem to believe that girls find computer science hard more than the girls do. And the older students, regardless of gender, agreed more with that statement than the younger ones. So basically, yes, you know, this isn't going away. There is still this gender difference in how people perceive computer science and boys and girls respectively. So after watching the video, boys in the argumentative condition agreed less with that statement. So it actually did seem to challenge a little bit, or at least make them reflect on what they thought about girls and being in computer science. Girls in the aggressive condition agreed more with the statement that it's important to encourage girls. So girls watched that video and said, oh, okay, maybe it is quite important that girls study robotics after all. But I think the big takeaway was in terms of the credibility of the robot. So girls ascribed the argumentative robot much more credibility than the control robot. So the argumentative one was the one that said, no, gender balanced teams make better robots, you're not right. Maybe a little bit surprisingly, the boys' description was unaffected. So in an ideal world, we perhaps would have liked to see the boys also rank the robots this way, but it didn't come out like that. But at least it didn't negatively impact them. So for boys, they were basically unaffected by these different versions of the robot. So this was good. We kind of showed, yes, the robot can fight back. That boosts the robot's credibility to the girls. It doesn't impact on the boys. Why would we not do that? But we didn't get everything right in this study. In terms of the students who watched the video, we asked them before and afterwards, how much would you like to learn more about robotics? And pretty much everyone showed a slight decrease in how much they would like to learn more about robotics. There's an interesting gender difference here in terms of this, the girls were particularly put off by the aggressive condition, whereas the aggressive condition is particularly the one that did not put the boys off. You can see the paper, it was an Alt HRI 2021 paper we just published. You can see in there for all the details, but what's more important, I guess, is, it's not clear, right? There's a bit of complexity here as to, oh, well, why didn't boys kind of liked the argumentative, the aggressive one, girls kind of like the others? Why is that? And when we looked at some of the qualitative data, what we found was that the aggressive robot was quite polarizing. So you have a range of quotes here saying, yeah, it's great that the robot stood up, and others like, no, it's not so nice, it was too harsh. And so, actually, we need to be really careful here when we're designing these robots, because, clearly for some of the girls, they didn't like the argumentative robot, they didn't like the aggressive robot. And so one might say it's almost like we should have worked with some other humans to actually design this robot, right? These were robot responses that I came up with, and so clearly they're not exactly participatory. And that's the work that we're doing right now. We just did some participatory design workshops with some students from that school to explore, okay, well, what do you think the robot should have said? Okay, I'm very close to wrapping up because I know time is getting on. So main takeaway from this work was we at least got some good initial evidence that we can challenge the status quo, and we don't need to keep having these subservient, kind of boring female personas. We can perhaps come up with something a bit different. Okay, so to conclude, I hope today that I've kind of shown, social robot behavior is important for socially assistive robots. It can make the robots more effective. Working with human experts during the design and development of these robots is the best way to tackle some of the hard technical challenges that we face. And there can be this kind of darker side to social human robot interaction, but if we're careful and optimistic and we are doing our participatory design, maybe we can turn this around and do something a bit more positive. So in short, as I set out to do, hopefully I have shown you that effective and meaningful human-robot interaction is best achieved by working with robots or humans to make better humans or robots. Thank you.
Thank you, Katie. I hope you'll send me your code because I would need some motivation now when the gyms are open in France. And yeah, the second project was really inspiring, and we would like to hear more about your future results. So perhaps for another geeky coffee break.
Absolutely.
Let's now move on to the Q&A section and see what our audience would like to know. Very cool project. Thanks for the insights, and I could certainly use a personal trainer. We all agree.
Yeah.
Some of Pepper's tasks could also be taken over by apps. How much more successful is Pepper compared to a tablet or phone?
Yeah, it's a really good question. And, when we were coming up with this study, it would have been really an ideal world. We would have had another control condition where it was just the app. And actually, the exercise program that we did, which is the NHS Couch to 5K program, it's currently delivered through a podcast. You download it from the website and you can go out and do your runs. We don't have data for this specific study. In general, in HRI, we have some kind of classic studies we all refer to where they showed that basically having an avatar on a screen is not as effective as having a robot in position. With this particular study, some of the, and this is a bit anecdotal, of course, we only had 10 participants, but a couple of them had used the podcast before and they had dropped out halfway through. And they commented in the evaluation afterwards, oh, it was so much more motivating to have somebody, as they would say, there to motivate me. So I think this is really going to depend on every different application. There are some applications, and for some people as well, I think a phone will probably suffice. But from what I've seen, I think there is going to always be people for whom having that physical presence just makes things better, just makes things easier. But I think we don't have stats to really prove that that's the case.
Okay, let's move on to the next one. Is the robot able to connect to a group of humans, making social links where the group seems off or without any communication?
This is a really good question. And I think a lot of us in HRI are moving towards this kind of scenario where we're like, okay, what we want to use the robot for is to create human-human interaction. And we're almost less, or at least it's a different kind of human-robot interaction. It's now really looking at how can we get these people speaking. There's already been some very nice examples of this in elderly care homes, in dementia care homes, where residents are sitting far away from one another and you want to get them talking. So definitely, this isn't something I've done, however. It's something I'm investigating now in some of my new work with robots and children. But I think this is definitely a use case that is worth exploring more and that some more of us are doing now. Yeah.
Great talk. I'm wondering, what are the perspectives of your work about feminist robotics?
Perspectives in terms of what people think, maybe?
Yeah, or maybe future work. I'm also
Okay.
not sure, but maybe you can respond quickly to both.
Yeah, sure. So in terms of perspectives, so there's a few things I can say here. Firstly, feminism is a huge new topic to me in terms of the academic study of feminism. And I've been doing so much reading, and I'm very fortunate right now to be working with some professors in gender studies, some professors in the social technology studies who have expertise in actual academic feminism. And so I'm looking forward to getting their perspective and working with them to make sure that we are kind of getting a variety of perspectives into the robot. In terms of how people are seeing this work, I'm really happy that when I published and did this presentation at the HRI conference, it was a really positive response. I was half expecting people to be like, this is silly, like, why are you doing this? Or this is kind of not relevant to robotics. But actually, people really engaged with it. And so I'm hoping that this work is well received by the community.
Yeah, it also attracted our attention at HRI.
Yeah.
Do you think that your findings transfer to digital human avatars?
Yeah, great question. So as I said before, I think we know that there are some differences between when you have the avatar on the screen and you have the robot. And we also tend to see, as you kind of said, human avatars tend to be more human-like. And I think that already starts to change a little bit, the dynamics of the social interaction. So I think there is some transfer there, this stuff about taking an interest in you and things. I think that does transfer. How believable it is when it's an avatar on a screen compared to a robot, even though they're both equally not real, if that makes sense. I'm not sure if it would carry the same persuasive weight, but I think there is probably some transfer there for sure.
Okay, let's move on to the next one. Your findings on the emergent synergy of robot, fitness trainer, and trainee are fascinating. What academic fields would you draw on to understand the emergent effects of human technology relations?
That is an excellent question where I'm going to be like, yep, I'm definitely an engineer and have had to do a lot of reading to understand what tools even you use to do this. So I can actually say a lot of this and these approaches was motivated by some really pioneering work by Selma Spanovich, and she looked at mutual shaping in robotics and talked about, so I think she comes from social sciences, again, social technology sciences, looking at how to really study when you drop a bit of technology into an environment, how to study the impact it has on that entire social context. And this is definitely where we should be pulling from, as I said, social sciences and the sciences, the social technology studies, people who know how to do that better. So you're thinking about ethnography, thinking about, social sciences, as I've said, psychology. So it's a bit of a messy answer because these are fields that are also new to me, but there are people doing really good stuff. And I definitely recommend, at least as a starting point, Selma Spanovich's work on mutual shaping in robot design.
Cool, we'll check it out. One more time, thanks a lot, interesting work. In your third case, the interaction started from a provocative perspective. How do you think the 3 strategies will be applicable in normal scenarios?
Yeah, so this is a good point, and there's kind of 2 ways that this was provocative. So firstly, the statement, the future's too important to be left to men. In Sweden, that is not provocative. As I said, it's a statement that's used from our university, but I think in other places, in the UK, it would actually be provocative to say this even, because it would be a bit male exclusionary. So I think that already sets a bit of a specific tone. But also, of course, the whole fact that it was abuse and that the robot was coming back to the abuse, and we wanted to have this provocative scenario. I think these strategies, if you consider normal scenario to be more like, I don't know, I don't want to do my homework, well, here's why you should, I think you would still see a similar kind of response, in that the one that gives a rational argument as to why it's either questioning you or why it's saying you do this, that probably works still the best compared to the other 2. But I think what was really kind of clear in our scenario in terms of the provocative, one of the reasons that people didn't like the aggressive response is because they perceived it as like this clever robot being quite harsh to a younger person. They were like, well, a teacher wouldn't do this. Maybe my friend would do this. Maybe my friend would call me an idiot, but a teacher should always be professional. So I think that's more where it would change. If you have a robot that is acting more like a friend rather than some sort of expert teacher, then the strategies and their kind of which one comes out on top might change a little bit.
Does gendering robots enhance acceptance by humans, or should the gendering of robots be resisted?
This is the killer question, right? So my mind goes backwards and forwards on this. We see sometimes that gender does play a role in acceptance, but we also see that even if you make a robot genderless, or you think you have, people still tend to ascribe it a gender anyway. It's because we're so used to seeing gender as kind of part of how we interpret the social people around us. That might change, particularly as we are seeing increased visibility of, people that are non-binary and things like this. It might change, but I think for now, I'm not sure we could really avoid the gendering even if we wanted to. So it's better to instead think, how do we make sure that we do it safely, basically.
Thank you. I built and programmed realistic humanoid robots in academia, nothing dodgy. Okay, we trust you. How do you think a more realistic robot would influence results in similar studies to yours?
It's a very good question, and I only have like a gut feel to go on, but I think definitely it would change. The question about, do we think it's deceptive? I think people would probably say, yes, it's more deceptive as the robot becomes more and more human-like. With Pepper, they can totally buy into it's just a robot, but it's kind of a fun social agent. If you've got something that's getting more and more human-like, I think people would, of course, get more creeped out. We've all heard of the uncanny valley effect. We kind of know that people get creeped out. So I think it would actually make the robot less appealing, and potentially people would find it more deceptive. Yeah, that's my gut feel, though. I have no study to back that up with.
Have you taken into the account the uncanny valley in your study?
Only really in the way I just described. So we of course asked people sort of how much, especially in the deception one, it became clear that, as I said, part of it was they knew Pepper, they couldn't be convinced that Pepper was a human, and therefore, you know, they were kind of felt okay with it. But I haven't done with Furhat. It's a more human-like robot, but I haven't really done any studies kind of detailing the differences. So I actually tend to stick with something like Pepper or the anime version of Furhat to avoid getting too high into that uncanny valley in general.
Okay, and I think this is the last question for now. We'll try to collect the other questions and perhaps post it in our blog post later on. We'll talk to you, Katie, more. Thank you once more, Katie. Your presentation was truly interesting and inspiring. And dear listeners, I hope you enjoyed our coffee break talking robotics. If you thought that this is the last hard tech talk before our summer break, well, we'll positively surprise you. At the end of June, two engineers here from SoftBank Robotics Europe will teach us about autonomous decision-making on Pepper. We'll share more info in the following days on our Twitter and SoftBank's social media, so keep an eye on it. Until next time.